So in this problem if the sprinter from the previous problem accelerates at the rate of 20 meters, at that rate for 20 meters, so she's accelerating at 4.2 meters per second squared for 20 meters, and then maintains that velocity for the remainder of the 100-meter dash. What will be her time? What will her time be for that rate, for the race? Okay, so what we want to do is, this is 20 meters and here's 80 meters. Okay, so she starts off at rest. What we want to do is find her velocity here, which is the velocity she maintains for that. Alright, so for the first part of the journey, v square is v naught square plus 2ax minus x naught. This is the velocity we're trying to find. This is 0. Her initial velocity is 0. Acceleration is that, and that's 20 meters. So v squared is 0 plus 2 times 4.2 meters per second squared times 20 meters. So her velocity at the end of 20 meters works out to 12.96, 13 meters per second. Okay, so we'll say 13 meters per second. Now, the time for part one is v equal to v naught plus at, t equal to v minus v naught divided by a, which is 13 minus 0 divided by 4.2 meters per second square, which is 3.1 seconds. So the time for the first part of her race is, she takes 3.1 seconds, and the time for the second part, so let's add a page below. The time for the second part of the journey is x minus x naught is vt plus 1/2 at squared. She's not accelerating in the second part, it's just her velocity, so this is 80 meters and her velocity is 13 meters per second times t. So t for the second part of the journey is 80 meters divided by 13 meters per second. .15 seconds. So the total time is t1 plus t2 and t is 3.10 plus 6.15 seconds. So that's 9.25 seconds. Alright, that finishes that